Who doesn't like ice cream? Let's go ahead and talk about ice cream. Last week you had an ice cream assignment to do for me. There was one error on it, which was kind of frustrating, but let's go ahead and go back and look at this as kind of an introduction for the week. What I want you taking away from this, I have a few people joining us that haven't really been able to access or haven't chosen to access this content for a while, so let's try to get everybody on board. When solving systems of equations using elimination, you're trying to find opposite pairs of numbers, either in the x column or in the y column. And if you see opposite columns like these opposite y's, or over here, opposite y's, this is great because all you need to do is add the two equations together. And in this pink example, x plus x is 2x, 12 plus 2 is 14, and the positive y and the negative y, they go away because positive y plus negative y is 0. So they simply go away and we can solve this problem pretty quickly. X was 7, you plug it back in, y became 5, and life is good. Right? Same thing over here on the red. I saw positive 5 and negative 5 lined up, so I added the two columns. 2x and 3x was 5x, negative 24 and 14 was negative 10. I got x as negative 2, I put it back in. I got y was negative 4, and I was golden. Now, they don't always work like that, however. In the question number 3, or the brown one, you find yourself with no columns that were the same. The y's, I had a 1y and a 3y, that didn't help me. And I had a 2x and a negative x, and that didn't really help me either because they weren't the same. But I was able to make a minor modification by multiplying the second equation by negative 2. I ended up getting negative 2x on the bottom and positive 2x on the top. And yay, I could add those then, and here we go. When I added them up, they went away, right? So we were able to manipulate our equations in order to get some common pairs. There's a couple great videos from last week. There's one with a guy in an orange tie. There's a couple videos from me. If you're rusty on this content, you can go back and you can watch those videos. Edpuzzle should show them to you. They're also on SV Math Teach as my YouTube. Where is it? There it is. My YouTube channel. You could go to my YouTube channel and you could find all of these videos, because to use Edpuzzle, I have to upload things to YouTube and then pull them from YouTube over. So one more time, check out SV Math Teach on YouTube if you need it. All right, as a quick review, the green one, I had negative y and positive y, so they eliminated, so good news there. The blue one, I had, okay, so check this one out. So the blue one was kind of a challenge. So for the blue one, I decided to go with the technique that we learned last week. I didn't see any common y's, and I didn't see any common x's. So I decided to go ahead and kind of do it's kind of like a cross multiply strategy. Here's what I did. I took the negative 3 and I put it here. And I took the positive 2 and I put it here. Basically, I'm going to go ahead and use the coefficients that are already there, and we're just going to multiply them by the other equation. So watch what I did then. So when I took 2 times negative 3x, I got negative 6x. And when I took negative 3 times 2x, I got negative 6x. And they are exactly the same. So then you simply subtract and they eliminate, right? So that's a key component of that style of question. This one in yellow is really hard to see, but I would want you to see that I had a common pair. I subtracted. Negative 5x minus negative 5x minus negative became plus, and they went away. So good job there. I had another blue. I had an orange one. In the orange one, I decided that I had a 5x, but only a single x in the top equation. So I multiplied it by 5 to get myself 5x and 5x, and then I subtracted. This guy here, I tried a different strategy still. What I observed, because I want you all to recognize that there's other ways to do this, I recognized that I had a plus 3y on the top, but only a minus y on the bottom. Man, if that were a negative 3y, I could just add and they would go away. So I multiplied by 3. And I got my negative 3y in my multiplication. I added the 3y that was above, and it eliminated, right? So it went away. So that's a key component here. And again and again and again, that's how we did everything else. I do want to make a note down here in the bottom left-hand corner. The purple one, the correct answer for the purple was negative 4, positive 1. If you got negative 4, positive 1, you did an awesome job. Unfortunately, negative 4, positive 1 is not what this person created. These documents are all created by other teachers, and sometimes they make mistakes. And this one was a mistake. I think they wanted this one, oh, wrong color. I think they wanted that one to be the purple one, but it didn't work out. So the correct answer was -4, 1. You're not doing anything wrong if you had this and it simply didn't match up. That was just a mistake on their part. And the last one, I couldn't write in white, so I wrote in gray, and I looked for here. I decided to go ahead and make those common x's. I multiplied by 4 to get 4x. I subtracted them and they eliminated. And again, the common theme here is that you want to make sure you have common x's, common y's, so you could add or subtract to eliminate. That's the idea.